I am apparently live. OBS for you. Yes. I think the audio is good. I took off the gain and I'm using the hardware gain instead. So it might sound better, might sound more awful. Also, this camera here, it's let me show you. It's 320 by 240 or 640 by 480. 320 by 240, not 420. 320 by 240 is 60 FPS, and 640 by 480 is 30 FPS. And as seen here, maybe you can't read, but it says iToy USB camera. Yes, it's a PlayStation 2 USB webcam. Because I don't have anything else. That's remotely good. And I choose a lower resolution and higher frame rates because I hate having video that's low frame rates, and especially when you have a mouth that's talking, you should preferably have high FPS to have it not look like it's totally out of sync. But I probably failed that already somehow because Linux. But yes, today, getting that out of the way, that's a joke. What the fuck you on about? I didn't stop streaming. Yeah, what the hell? Fuck you. Damn you. Video output low, no. Stop doing this, please. I'm using your recommended... Oh shit, dropped frames. A lot of them. Quite a lot of them. I may need to change. Very fast. Is that gonna help? We dropped CPU a bit. We are no longer dropping frames. We've dropped 974 frames so far, and the percentage is decreasing because we're generating more frames and the drop frames is not going up, so I guess that fixed it. And hey, props to OBS. I didn't know it could actually switch encoding settings midstream. That's kind of cool. Or it didn't change anything and I'm just imagining things. Anyway, that's out of the way. What we're doing today is... What is that buzzing sound? Hold on, let me check something real quick. And am I also... No, mine is muted, what the fuck? This is weird buzzing sound in my ear. Anyway, we are writing a 6502 variant emulator, also known as the NES CPU. So I haven't really gotten any longer than defining the registers, program counter, stack pointer, X and Y index, program flags, interrupt, reset, the non-maskable interrupt, the break, and then I define the memory inside of the processor class because it's faster, it's easier. From the beginning I was thinking I would make a class for processor, I would make a class for the RAM, I would make a class for the PPU, I would make a class for the basically everything and then somehow interconnect it all, but I never figured out how to interconnect it all like efficiently, because this is going to be a emulator running instructions at about 1 megahertz, and the PPU will run instructions at 3 megahertz or somewhere around there. So this code needs to be fairly lightweight, and the first thing I'm gonna make here is a CPU memory mapper. It's basically gonna be a function between reading from the bus, and it's just gonna sit there as a man in the middle and just check the values, and if it's in certain ranges, it's gonna map to appropriate stuff over here. So, and that's what I like about the NES processor. It's basically your processor, your RAM, and you're always using your bus to interface with the RAM and all the other peripherals. So your bus input and output is really your central or your main way of communicating with peripherals of RAM. Yeah. So bus read, and it's given an address, and yes, is first of all, I don't totally know my Python. It was a while ago. Is there a switch case in Python? Or is just the if-else compiled down to that speed? Using a dictionary? Yeah, we could put all of our stuff in there. That's not really ideal though. Lambdas. Also using a dictionary. And here's just a if elif. Is that a fall through though? Fall through by not using elif, but now the default case includes case A. Parts of this is logically redundant, like the B in could have used anything else, but whatever, I get what you mean. Well, let's not dwell on it. Let's just go back to our CPU memory map and let's start writing something, I guess. So 00 to 0000 to 07FF is your 2 kilobytes of internal RAM, and 0000 to 1FFF contains that 2 kilobytes. It is replicated 4 times over and over. So first check if we want to read from RAM, which we probably want to do most of the time. So if address is less than or equal, because yes, that feels weird, but I guess 0x1, no, not that, 5. So if it's within that range, then it's in RAM. So let's say that in RAM. So we shall return. Oh Jesus, I forgot Python self. And include the self. Jesus one. Self.memory, which is our 2 kilobytes of memory, and we want to index that with the address. I assume it's a global address for now, and I'll define everything as it's global, as it's like a global position in RAM or something like that, and then if the functions or the opcodes that needs relative and absolute addresses can have that calculated within them. Yes, because the program counter is actually gonna read through the bus read, and then it's gonna need to jump to a reset, which is in the cart, which runs the cart. That then boots the game up. And I guess that would be based on global addressing. So I'll stick to global addressing in this generic bus read function. Bus mapper, it should really be called. Well, I'll keep the same. Yes. But this 2 kilobytes of internal RAM is replicated 4 times, so we can modulo it with the length of the RAM, which is 0x07ff. Now I should define somewhere up here, like as some kind of setting. So I can set an amount of RAM. No. Although I would probably do need to reference the size of the RAM several times, so I'll go ahead and define that somewhere. What should we name it? What to name? RAM size? RAM size. Zero x07ff. I mean, I could do this. But this would make it really like incompatible with any game if I change the amount of RAM, because then the RAM will be spanning into the PPU registers. So I'll actually keep that hard-coded. but not that, because I don't know. So we have mapped it to RAM properly, hopefully. Then we have 8 bytes of the PPU registers. Think about that. All the things you see on the NES is communicated to the picture processing unit and onto the screen through 8 registers. That's not a lot. Because it spans from hexadecimal 2000 to 2007. So I'm basically gonna lay up this checking, so we're starting at the bottom and then we're basically going upwards, so we never have to check a lower bound, essentially. So I'll only have to check an upper bound, because the RAM has an upper bound of the RAM's upper bound and its lower bound is inherently 0. And then the PPU registers, which are directly after that, you know where they start because they start directly after, and then you only need to know where they stop. So I only need to do one check that way. So if address is less than or equal to 0x 2007 in PPU, pass. Maybe I'll have the processor load in the PPU class that I'll create later. Actually, before we get ahead of ourselves, NES PPU, let's see what it actually is, if it's like a similar processor or if it's completely like dedicated. PPU control register, the first register. Ooh, I'm gonna have to get into this. The last register is the data register, apparently. Oh! Each PPU frame is 89,342 PPU clocks long. There is no skipped clock every other frame. The fuck? With rendering enabled, each odd PPU frame is one PPU clock shorter than normal. Yeah, I'm not gonna get into the PPU, that's a whole other thing. I just want a processor that handles RAM right now. What am I even doing? The fuck, okay. What did I do? What did I close? Oh, the downloads. Rip. Now y'all know what I downloaded. Shite. Yes, this was the page I was looking for. So let's not care about the PPU. Elif address is less than regrett. Oh, I forgot to read the next block down, which is just, as with the RAM, it's a copy. So I need to define some. I could do this later, but no, I don't want to do this. Whenever I'm defining the PPU, def init. Self dot I am thinking to whether or not define the PPU registers as in a table or array, which would make it easier to access them from the CPU. But why do that when I can just create a mapping table in the processor? It's a mapping table, it's going to take more time, not optimized. So yeah, let's check. Let's PPU registers are repeated from 2000 to 3FFF. It's quite a lot. No, 3FFF. So Actually, I should not have this as a dedicated read because I'm gonna do writes as well. So I'm just gonna do bus map. Gives address and it spits out. What's it gonna spit out? What you're gonna interact with. And where? What? There needs to be a better way to do this bus map function. Yes. Oh, we have more drop frames. How wonderful. Ultra fast apply. Get ready for quality getting wrecked. Like literally. Let's disable the preview and see if that helps. Fuck all it does. Whatever. Let's see. Okay, this is all of it. Ah shit. I'll return references to the thing and where that is in that thing. So this is obviously not going to return self.memory. Also, I realized that taking the address and just moduling it is probably not going to work. I need to negate the base address, which for the RAM is obviously 00, so there it's not needed. It is needed down here though. So self.ppu is actually not defined, but ergo ppu is not defined for some odd reason. I have to define the sound processing unit later as well. I just realized what a big project this is. Help. Well, I'm not gonna get help. That's for certain. Oh yeah, I popped out that. If there's a live chat attendee, I have a chat window that's probably not going to be interacted with much. Videos here, when we're addressing the PPU, we need to remove the base offset of the PPU, which is 2000, 0x to 000. Yes, I'm gonna define it as registers. Kill me. and I'll have the map inside of the PPU itself. Yes. How many were there? 8? BB4 underscore X range 8. Stop it, Nos. You're killing me. Oh, now I'm numb. I can't feel my nose. Jesus. Yes, 8 of them registers, all of them default to 0 for now. For now, not forever. Big distinction. Otherwise, that's F. Then it's the APU and IO registers. The IO registers is where your controller actually goes. And funnily enough, the NES controllers have 8 total inputs. 1, 2, 3, 4, 5, 6, 7, 8. Which takes up a byte. So it can be nicely just shoved into the operand of the processor and just process your controller essentially as a register or as an accumulator or basically as RAM or as anything. So that's what we get here. So if address is less than or equal to 4,000. No, I'm checking upper index. What the fuck am I doing? Is that right? Yes. 0x. So that's 4,017. From 4,000 to 4,017. You see this before goes to free FFF, the next one free FFF, yes. And the next value after that is 4000, so now we need to do one check. That's not duplicated. So here we go, APU and IO/O. I have no idea what to do. (4000 to 4017 is NES APU and IO registers. 4018 to 4001F is APU and IO functionality that is normally disabled. See CPU test mode. Let's check that. Pin 30 of the 2A03, which is the actual revision of the 6502 that the NES has. Revision G can be activated to enable a special test mode for the APU. This activates registers for testing the APU at 4018 to 4001A
at the expense of deactivating the joypad input registers at 4016 to 17. Visual inspection of the original 2A03 version indicates that there was planned IRQ functionality from blah blah blah, left unfinished, non-usable, was outright removed from later CPU versions. So I'm just not gonna bother with it. I'm just gonna have it as our map space. I need to check out where the limit between the APU and the I/O registers goes. Looks like all of the registers from 4000 to 4017 is used by the APU. Delta modulation channel outputs a 7-bit PCM signal from a counter that can be driven by DPCM samples. That's the status. The status register is used to enable and disable individual channels. Still APU frame counter. Okay. So 4000 to 4017 is basically just APU related stuff. Joypad 1 and 2 is stuck on register 4016 and 17. So but why is joystick data 1 on the same address as joystick strobe? The hell does that mean? Control F strobe. No strobe. I'm at a loss. Frame counter control. Well, I'll change it to 215 to be APU, and I'm gonna give it address negative the start, which is 0x4000. And we're gonna, what the fuck am I doing? Yeah, no, we're gonna need to modulo that because it's not repeating. And then we got joystick 1 and 2, which I'll implement here.
if the address is less than or equal 0x416, we should make it like that to make. I mean, seriously, the math, the APU, not the audio processing unit, but the arithmetic processing unit in modern processors these days, doesn't take an extra time to do a greater than or less than and operation. It takes just as long time as an equal than. It's so for semantics I'm gonna keep it the same. So if it's less than or equal to 4016, which it will only be equal because it can't be less, because then it will be catched by this one before. Right, whatever. We're gonna have joystick 1, joy 1, LAF, not L5, LAF address, less than or equal to 0x40117. Okay, so player 2 controller, joy 2. For now, just passing these. Let's define the APU as well. Class APU. So, how many registers do we got? 15. Including 0 at 16, so wait, let me check myself. 1, 2, 3, 4, 5, 6, 7. 22, because it's hexadecimal. Let me check that real quick. Yeah. It's in 21. I'm offended. From 0 to 15 inclusive, so yes, it is. Ah. $22. I find it ironic that the audio processing unit has more registers than the picture processing unit. Herm. Accidental mini tidal wave. So many tabs, I am confused. So that's out of the way. And then I'm basically gonna ignore this APU and extended APU functionality. So ONF address less than or equal to 401F. Wait. What the hell? It says 18 registers. 18 hexadecimal, which is 24. So maybe there's 24 registers, I don't know at this point. Help me. Okay. Yeah, I'm gonna promptly give up. No, not yet. I'm not giving up yet. So, if you are within the 0x401F zone, you are in the normally disabled APU and IO functionality. So we'll do MISC disabled. I'm not even gonna respell that. Fuck it, that's a report. Now we're accessing that cartridge. And that's our cartridge. No, not S, Control S. Big difference. One puts a character in a file, the other saves the file. Should I have an external or internal reference in the processor to the cartridge and joypads? Or somehow external? For compatibility it needs to be external, but I don't know how to do that. Like efficiently, or like at all, kind of. Shit! Actually, first of all, let's get a NES test cartridge, or a NES test ROM, NES test ROM. Emulator test. Hey, Biscuit! I didn't know Biscuit actually wrote some tests for the NES. Test ROMs, I mean. How many has it written? 1, 2, 3... Yeah, 3 of them. 4... Yeah.
CPU tests. So test official and unofficial CPU instructions and lists which ones failed. It will work even if emulator has no PPU and only supports NROM. What's NROM again? It's not that ROM, it's not SHA ROM. I have no idea. Writing a copy of output to memory address 6000. Yes, let's see if there's another one that also works without PPU. Ooh, RAM isn't changed during reset. That's a thing I have to like keep true to. I'm trying to make like as fast but also as accurate emulator as possible. Because I think we're getting the instruction test version 5. So on instruction or only NES, readme. And that's kind of shit, the testing. Source. Wait, you can actually compile. Oh my god, it's actually assembly. Hey, oh, hey, look, it's actually checksumming the RAM or something to check if its tests were accurate and passed, I guess. 0 page, let's look at that. Correct checksums, which is a label, and then it's just a bunch of D words. Double words! I didn't know there was actual compiler for this processor. Well, now I know. Common shell. Well, I'm gonna start looking at that. It's not the right folder here though. Let's copy this to my location, new folder called ROMs. Question is, will this work? No, for shit because Linux. So what do I have to do? I have to go to fuck it, I'll just download it again. It's easier. Official only. Why do you do this? What? Well, there we go. I wanna see if the .NES file here is just a straight ROM dump or if it actually has some headers. So I don't know, open with leafpad, I guess, if it's here. Okay. Yeah, sure. What's the size of this? It's 262 kilobytes. So yeah, there is data in there, supposedly. Let's view it in Sublime. It looks like a ROM dump. Yeah. And here at the back somewhere, there should be the IRQ handlers. Maybe it does. Who knows? Who knows? It looks like it's 4862. First 32 bytes looks like they are a checksum, but NES file format. Sure. Then explanatory. So first three is just NES. Okay. So there are pages for the character and program ROM. I guess I have to create a new class called Cart. Oh, my life is getting so much worse by the minute right now. This is awesome. Cart. How do I spell cartridge properly? Not that kind of cartridge. That kind of cartridge. Cartridge. Cartridge, really? Whatever. Here's where we're probably gonna probably gonna read some fast Python. Sysarg. Okay, so I guess we need to import sys to get sys.argv. Argv. I don't know why I like it, but argv is fun. self.rom equals
Ooh.
Ooh, now I'm treading into very much unknown territory for me, because the cartridges, I have this thing called SHA-ROM and PROG-ROM, and I don't know if they sit on the same program and mapper registers. It's all just baked into the cartridge space. Sample RAM app. You have 8 pages of 256 bytes. Wait, hold on. From 6,000. Okay. So the program begins at 6,000. Does this thing have a OAM? Oh, the PPU OAM. Oh, that might explain why they only have 8 registers. Because you're doing many copies. I have no idea what I'm reading at the moment, so yeah, this is very, very interesting, to say the least. I don't get what all of these numbers are. Maybe I need to read some more of this. What are these numbers? I've treaded so deep into the swamp I don't even know where my nose is anymore. I mean, it's just letters and numbers at this point. What the fuck am I? How does this number identify the mapper? I don't get it. Also, why am I reading about mappers anyway? Oh yeah, because memory and cartridge. Okay.
Yeah, that's just incompatible.
Mapper number.
NES mapper number meaning. For fuck's sake. MMC. Wait, is this memory management chips on the cartridges? Yes. Mm-hmm. I don't want to get into this mapping shit. I don't really want to go into ROM mapping. They have a memory management chip put on cartridges, or bank management chip, that also contains a Yamaha YM2149. That's a synthesizer chip. It can create sounds. Talk about multiprocessing there. Just slapping dice together and hoping it works. Yeah, this was all just confusing.
Let's not read about this. Let's just read about the INES format. Could we do that somewhere? Where was I? Psycha Blyett. I've lost the page. Seriously, what the... And here we are. Yes. Define a load function with file. That is empty, I guess, with f as no. How is that going in Python with as? Okay. And don't worry, we're gonna open it as read-only and binary, so RB. So I currently have two Py files, one called ember.py and one which is run.py. Run.py simply just imports the emu and just creates a processor. So, no, I don't know. Anyway, let's just do this. Let's just have everything be self-referential inside of here. I'll do that for easiness. Yes. Now theoretically that should actually print if I put that somewhere like there. No, it won't because it doesn't load it. Well, call the load because init doesn't call load. I think that's fine. So now we're gonna read it works, and then we're hopefully gonna print out the ROM. This is not gonna work first time, I guarantee you. If it does, I'm gonna give myself something. Didn't work. Shit. Expected an inland block.
Yeah, that explains.
Shit. Let's try that again. Is that better? No, freaking. Come on! Okay. Fuck it. I'm gonna go to the toilet because I need to go to the toilet and then I'll come back. Also, it's hot as it balls in here. Even though I got a fan going over there, I'm pouring sweat, Jesus. But I'll mute myself and I'll go wipe this off, I guess. I am back, and that's a preview, which I do not want. And yes. Hey, let's check that chat that I pulled up like ages ago. Empty, as I said. Correct again. Now. Stupid. Yes, I want to interpret the NES file so I can actually somewhat just load it into RAM. But yes, it was failures, so let's look at those failures. What? Byte is not defined. Shitty me. Oh, this is new. Huh. Why is there no byte object on Python? Oh yeah, Python 3 has arbitrary length integers. So this BB thing, which is this bytes, is probably not good. It's gonna be defined with as few bits as it needs, so it's just gonna be defined with 1 or 2 bits, I think. And this grows from there, depending on the number. Boop, boop, 0, 0. Short is not defined, oh yeah, because arbitrary length IDs again. So we can set that. I may make a note here just to remind myself that it's 16-bit. Missed index out of range because I didn't give it the file. ROMs. Load takes exactly 1 argument to given. Oh, because I didn't define self. Idiot I am. That was probably the ROM. Let's do it again. Shit, yeah, that's probably the ROM. That's interesting though. It looks like we can't get... It's printing so much that I can't see the first bytes of the ROM, so let's only print the first bytes of the ROM. Let's print the first 100 bytes. Mem size is not defined. Is it self.mem size? That would be half done. Oh yeah.
It's not half done actually. It's just I mean, yeah, as it's laid up now, the registers, the program counter, and everything like that gets created. My speakers is turned off. Ouch. What was I saying? Well, I lost that thread, whatever. Let's change it so if only print the first 16. Which is a bunch of crap. What happens if we represent that? So we have NES 1A 10 00 11 00 00. Now, what does that mean? I don't know. Let's check it up on those webs. Where was it? Here, yes. So byte 4 is the number of ROM pages, or program ROM pages, and byte 5 is number of character ROM pages. 0 indicates char RAM. I probably don't have to care too much about that, since the way I'm setting this up is that the processor it's allowed to write and read anywhere essentially within its range. Maybe I'll set it up like that. I know that's not the best way to do it. But let's if that the first 3 of them equals NES, then print valid ROM. Yeah, put that in that string, mate. Run this and see if it actually detects it as a valid ROM. Yes. So I could do that shorthand. I thought I may have to like put a wrapper or string in front of this, but apparently strings and tables are almost the same and can be directly compared in Python. So it is a valid ROM. What do we do next? Next we check the number of pages and stuff. So P-ROM, no, P-ROM, no, P-ROM, and C-ROM. Equals data number 4. And the C-ROM is data number 5. And if C-ROM is 0, that indicates char RAM, which I need to read up on. Bit field. hashtag TODO : hate writing that. Mapper identification and header parsing is on the to-do list. What the hell is Place Choice 10 in Unisystem? Huh. It's so hot in this room, I'm literally cold sweating. Hold on. Let's see if opening the doors helps. Oh no. Damn microphone. That was mostly right, so... Oh my god. Oh, the whole subject of mappers is like, oh, we base, because mappers, if you don't know how it works, mappers is basically the ROM dumper's way of replicating the multiple pages of ROM that would be in the NES cartridge, because the NES processor can only access so many bits and zeros at once. And some games were bigger than that space, so they needed to have a chip that read from a register or notice when the processor wrote to a specific register, and it would catch that and say, oh, you want bank 4, oh, you want bank 2, oh, you want bank 0, and it would switch out banks. And that's hardware. When reading about the mappers here, it's you're recreating hardware and software, and all of the edge cases is just hell. Just hell.
Yeah, I mean, this header identification is really not needed. Yeah, I could do all of those validity checks, but I'm just gonna assume this is a valid ROM. This emulator I'm writing here is not gonna do any security checks whatsoever. It's just gonna run the thing. Who the hell cares if you execute code in PPU space or APU space or cartridge space? Bay. Writing into cartridge space, yeah, that theoretically you in this emulator you would be able to change ROM if you just wrote to it, which is kinda awful. But A. But A. But A, but A, but A. So how do I the program ROM and the character ROM, are they located directly after the header? What's the trainer? If present, how do I detect if it's present? Okay, so I need to take care of byte 8 as well. So we have program ROM, we have program RAM. Is that 8? Recommended detection procedure. If byte 7 and location 0C is 08, then the size taken into account by byte does not exceed the actual size of the ROM image, then NES 2. archaic Ines. Really? Why are you doing this to me? Oh, hello. Bit 1, 2, 3 on byte 6 says if the trainer is present. Why do I say data when it's that? Stupid me. That. Which byte? Oh, that's the length. I was like, what? What's that 1111 for? And I forgot how to check bits in Python. Bit check. That bit manipulation. Okay, sure. If that data and bitwise and it with 0b, which bit was it? Ah. Okay, so the first bit decides how it's laid out, either, I don't know how, but horizontal or vertical mirroring, whatever that means. That's RAM enabled, and then the trainer. Third bit. So 100. And if that's not equals 0, then the trainer is on, or enabled, or is there. What? 01 equals 00, which is NES ROM. 01 equals 01, which is VS Unisystem ROM. 01 equals 02. What the fuck is all of this shit? Oh, extra RAM, blah blah blah. Okay, so I don't really need to know much more than that. Then I just need to know where the trainer starts. Trainer starts right after the header, right after the trainer starts the ROM, I guess. So we know the trainer is 512 bytes, so self.rom is that, but only a specific part of it. Only the last 512 plus 16 if trainer else 16. So that should I just realized I can't really load this module in and load things on the fly. But that doesn't matter because we're not working anyway. It's unsupported operand type of string and char. Let's turn this char into an ordinary character. There we go, it did something, but we don't know why. And it's gonna fail me now. Like, majorly. This is not gonna work. Yeah, can I like bring up a command prompt whilst giving that sysarg? Like a REPL? Where's my REPL? Darn it. Oh, I could just do as before, but I run with interactive, which didn't work. Python -I run. Now I'm in a REPL and I probably had access to P, which is a processor. P dot memory empty. P dot cart is a cart instance dot rom. There it is. And that's probably some ASCII text. Yeah, okay. I should start implementing the freaking opcode soon. All we've been doing so far has just been data management and flow control, essentially. Where does the ROM start? It starts at somewhere 4020 0x4020. So I have a bus map. Now that's gonna be easy to work from, and we'll define our bus read self address self.busmap address. So we give it the address, and it will give us the object that we want to interact with and the address local to that object, like local to its array. Maybe that's a good way of doing it. I don't know. I've no idea. This is my first emulator, as I've said. So we get our object and an ADD here. So there's our read, which is really simple. Write same but what do I want to write? Hello. Yes, I'll give it the parameter value. I'll do that map thing again. Return, no, not returning because we're setting here. Object, the index of address equal value. So there we go. Our bus mapper is done, or our memory mapper is done. It should work. Should and will are not the same thing though, remember that. Because I forgot that. Yes, it's been a while, I know. Yeah. Let's see if we can test the bus mapper manually. Bus map 0x4020. That's gonna be just in the cart. Processor has no instance. Has no attribute. Processor instance has no attribute bus map. but I just called it and I know it's there. What's in P? Everything except the functions. No! Oh my god, I see what I've done now. I've defined functions instead of functions. Ugh. That's disgusting. There we go, now we got bus map, bus read, bus write. P dot bus map 0x4020. It gave me that entire array and then the index 0, which is correct. That should give me entire array and 1, yes. And if we read from below that, we'll get nothing because that's the MISC stuff. Let's read from 416, which is controller which is disabled, 417 also controller which is disabled. Let's read from the APU, which will return that. What? One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4. Ah, because I'm using the wrong register. Yes, I'm negating the wrong values here. 415. What was it before? 400. Why the hell? Let's go back to the website because I actually have the numbers. I need to write that right now. And what I need to write is okay. Let's do some actual writing. So let's write to RAM. Let's write to 0x 0606. Why not? Now we're gonna write 254 and p dot bus read 0x 0606 returns the same value. Nice.
And if we do the p.bus map 0x0606, we will get probably the RAM and what position we are. Yes, here's all the RAM. There's our lonely 254, and here's where it is in there. So yeah, I think this is going forward rather smoothly. Now when we got memory map complete, let's actually implement the opcodes and see if we can execute code. However, I don't know what happens. I mean, when you power this thing up, you probably hit reset, which throws it to FFFC or FFFD, or just, is it the first or the last or anywhere between that, or is it just a range, or what is it? Yeah. What do I need the... the Chrome Pram and Chrome for? I mean, it's all in the same address space. And I get that the mappers would fuck that up. Well, I will not dwell on that. I think I will not dwell on that too much. What I will dwell on is those vectors. Actually no, because those vectors are pointed to the cartridge, so that data is already set by the cartridge. Okay. What am I looking for? I don't know. Yeah, here. So these bunch of vectors are pointed to the cartridge. So I don't need to define that, it just goes there and executes by itself using the program counter. And yeah, I guess the first thing that happens is that we do a bus read. Do I have to do self.bus read? And we are gonna read whatever it's in our current self.program counter. And let's bring up that piece of data that you haven't seen yet. Yes, I've had this in the background the whole time. It's basically someone compiled everything they know about the 6502 into a single text file.
which is really handy. B is set to 1. Oh, the program flag B. Okay. I was like, what? There's no register called B. What? I'm confused as hell. Okay. Alphabetic opcode listing. Is there like hex? Yeah. A no break is one of the first instructions. Yeah. Well, I guess we go to the alphabetic opcode listing then. That is not. Has to reset. Further down. What? Source. Pre-indexing? What the hell? What have I gotten myself into? Oh, X and Y are modifiers. Eh. Didn't know that. Can't get too cold already. And with carry. I'm gonna refer back to this spreadsheet I have. What's this reference? I don't get it. Okay. First one, break references to 9, 17, and 22. Yeah, I can't get my head around that software either. What's the references? Here they are. No. What? Oh, opcode format for the. Okay, I'm going to task. Can I please find a set of instructions that are not only for other CPUs? Come on. Where's the beginning? Okay, I'm gonna do something. I'm gonna load up that thing and I'm gonna read from the bus. I'm gonna read the reset vector 0xFFFC. While running test. Yeah, there's actually text in here. So there's no opposite way to where. I'm trying to find the actual instruction. Let's jump to the IRQ/break. Nata. Do I need to actually implement a mapper? Yeah, okay. I have the opcodes here, but I have literally no idea on where to start. Yeah, I'll start here. So, to use a dictionary or not use a dictionary? That's the question. Opcodes equals that. Should I call it? I mean, I do wanna reuse functions. Okay, yes, I'll reuse functions. I'll call them _func, I guess. Let's make this somewhat more watchable. Question though, how do I indicate the mode? Modes is it's gonna be think I know how to do this. Ooh. Wow. Six, 502 modes. Actually, I might be able to make that as a hash table. Python hash table. Oh, dicts are already hash tables. Should really... maybe... I'm currently writing the processor as if the registers are separate from the bus. They are not. At least in a classical CPU. All of the registers are also laying on the bus. Indirect index, direct index, what the fuck is going on here? I don't get what is going on. I don't get half of this. Immediate. The operand is used directly to perform the computation. I don't know why I settled for lambdas, but here we are. Immediate. It's gonna be processor dot current counter +1. I'm just gonna return the value that's needed, so p dot bus read program counter +1. A full 16-bit address is specified, and that byte at that address is used to perform the computation. So it's just straight lambda. I don't get this. Hold on. Okay, accumulator implied immediate What? I don't get this. It's used what? I made a major mistake somewhere and I haven't wrapped my head around it yet. P dots. I don't get this. The way I'm defining it is immediate and absolute are the same, but it's not what? So we read the program counter. We read. No. We use the program counter and read from RAM. And from there we get that. And then we use the number we read to read once more. Huh? Sure. However, it's 16 bits. Yes. Zero page. Oh, the P I'm using here in the lambda is just self-reference to the processor. And that was 0 page. I missed something very huge. I bet I'm cooked for it. There's that one table. Ooh, power up state. Ah. Ah. Okay, so I have some default power up stuff. What is P, mate? X and Y are 0, yes. This is FD. So XFD it is. P, what P? Is it the program counter? Yeah. I have no idea what I'm doing. I bet you can see that from very far away. Pew pew power up state. Okay. What? So I might just stay on this. Okay. First of all, I didn't know you could do stuff like this. Here. Relative. Mm-hmm. None of this is gonna work. I think maybe. How is that signed? Just gonna negate 128 and hope for the best. Yeah, sure. Why is it so hard to keep track of these freaking tabs? Oh, I'm tired. So it's only one there, it's only one left. Indexed, indirect, indirect, indexed. What the fuck is this I'm not getting? Okay, that's like half stupid. That's all. That's all the addressing modes. I think I'm probably not done with it yet, especially not number 3 here, which is probably wrong. Now we can move back to the opcodes. I'll group them in a way, I guess. Let's go back to that nicely. Laid out piece of yeah. The implied mode should be mode 0, by the way. Yeah. Indirect. The fuck does that mean? What? What the what? Oh, look at that. So now I have to blend in the fucking these are gonna be like the finding freeze. Because now I'm gonna need to registers. Damn it. Zero is lambda p dot a. Get x, get y. Okay, I think I just solved my huge issue. Probably not though. Oh, come on. So the break function, let's go back to it. Implied. Of code 00. Oh well. Aura. Or with accumulator. No, that is 0, 1, and 0, 1 is 0 page with X. So 0 page is 4 and X is 1, right? Yeah, I think this might actually be runnable in the end. And then there's another aura, ORA, but now at O5. 0 page. What the hell's the difference between indexed and indexed indirect? I am amazed. Zero paged indexed indirectly. What does that mean? The value in X is added to the specified zero page address for a sum address. The little endian address stored at the 2-byte pair of sum address and sum address plus 1 is loaded, and the value that address is used to perform is loaded, and the value at that address is used to perform the computation.
I have no idea what the fuck's going on. Help.
These are the 13 memory addressing modes. So I guess I'm missing some. Yeah, after relative, I'm missing some. Hopefully lambdas can have 2 parameters. Hey, look, I should be going to bed, but let's like not. Abs index with X. The value in X is added to the specified address for some address. What is this specified address? Is it the current program counter? Is it the primary operand? Let's read the example. The value O2 in X is added to C001 for a sum of C003. question, does the NES CPU even support all of those operations? Yeah, I'm getting off topic. Uh, six main addressing nodes. Which are those? And then it goes got these ones which I defined. I am not making much progress. Of course it doesn't run. Oh yeah. Passing a lambda. Lol. No. Yeah, shit's not defined at all. I need to get all of these concepts straight and like work out what is what exactly, because there's loads of ambiguity here for someone that's never done this before. So yeah, with that said, I think I'm gonna kill the stream. Videos. 3 hours and 23 minutes of just staring at Wikipedia articles and occasionally fingering in some code. The most boring live stream you have ever seen. I congratulate you for surviving. Goodbye.